Basic features of OOP. Today we'll talk about the basic features of OOP. There are 5 features: data abstraction, data encapsulation, then modularity, inheritance, and polymorphism. We'll discuss all of them one by one. The first is data abstraction. It is the act of representing essential features without including the background details, which means this data abstraction, it will represent only the important features. Those features which are not important, those will not be represented. For example, when riding a motorcycle, we know only the acceleration, the brakes. We don't know how the engine works or how the internal features work. So we only need to know the important features, such as how to accelerate, how to apply the brakes, all these important features. So these background details, they are running in the background, so these features are hidden. So this is what data abstraction means. The background details are hidden and only the important features are displayed. One example will be functions. When we use functions, in a class we have methods. When you use methods, we can use the important functions without thinking how these data types and all these are represented in the background. So the number 2 is data encapsulation. Data encapsulation means the wrapping up of data and functions into a single unit. This is simple, and this definition is also correct. Class XYZ, okay, this class is encapsulating, which is bringing it together, the data and functions, into one unit. This class is a single unit, and this data and functions, they have been wrapped inside this single unit. So if we want to use any data or function, we have to use through this class, through the object of this class. Okay. Then the third one is modularity. Modularity is the act of partitioning a program into its individual components. Individual components, yes. When we use functions, libraries, or objects, then we divide the program. The main program, we divide it into smaller parts. And when we divide the program into smaller parts, it becomes easier to manage and develop. It scales up the development purpose. So modularity, when we create functions, we can maintain them separately. Libraries, the header files such as hash include. Using this preprocessor directive hash include, we include the files such as math.h. All the math libraries, math functions can be included. So this separate, they are developed separately, and hence this is how modularity works. Objects also help us to treat data and functions separately, and we can check them, test them, and create them separately. This helps to build the application better. Number 4, inheritance. It is the capability of one class of things to derive capabilities or properties from another class, which means here in C++, with respect to inheritance, the syntax is there, but if we take an example such as animal, if we take think animal as a class, then animal will have some properties such as hands, eyes, all these basic properties. So this mammal will inherit all these properties from animal. This mammal may be warm-blooded, will have hair. This will have extra properties of its own, but it will inherit some of the properties. All the properties will be inherited from the animal, and plus it will have some extra properties. Now human inherits again properties from mammal, and it will have some extra features such as thinking capability, eyes, 2 hands, 2 legs. All these are unique to human. Now student is also a human, but it will have some extra characteristics such as it will have its subjects, its name, roll number, it will have its class. All these properties will be there here. Now the 5th one is polymorphism. It is the ability for a message or data to be processed in more than one form, which means suppose there is a function or operator, it can have more than one meaning in C++. Suppose this function shape, yes, all the shapes have an area, but in circle, the area of circle is different, the triangles area is different, the rectangles area is different, all the formulas are different, but the area function, this is working differently with respect to different shapes. With circle is working differently, triangle, rectangle, same. In the same way, if we consider the plus operator in C++, plus operator can add two numbers such as 2 plus 3 equals to 5, or it can add two strings such as name. If you give name plus dog, then the answer will be name dog. It combines the two strings together. If we use it on strings, it will behave like that, and if we use it on numbers, it will behave like that. So this is the ability for a message or data to be processed in more than one form. So this plus operator behaves in more than one form here, and this is the same with the function also. Next, the implementation. This is the last part. This is how these all properties, these features of object-oriented programming are implemented in C++. Data abstraction. Data abstraction is implemented through methods and access specifiers. With methods, we can, like getters and setters, we can get the value of an object, or we can perform some function with methods. And with access specifiers, we can hide the data, such as in private, it will be only available to the class, and in protected, it will be available to all the derived classes. In public, it will be available to everywhere in the defining the place where object is defined. Next, encapsulation. The way encapsulation is implemented is by using a class. This is the simplest one. Just the way we define the class, in there itself the encapsulation gets implemented. The third is modularity. In modularity, when we create objects in C++, also with functions we can implement it, but object is our main concern here. With objects, we can create different objects from a class, and each of these objects will have its own data, its own functions and methods, so they can be maintained separately. So this is how modularity is implemented. Then next, fourth number is inheritance. In inheritance, and this is the syntax of inheritance, class derive, then this is the visibility mode, then this is the base. Here all the derived properties and functions, methods will be there, and this is the base class from where it is deriving. Suppose it is a student, then student derives from human, or human derives from animal. Number 5, polymorphism. It is implemented in two ways in C++: function overloading and operator overloading. In function overloading, a single function can behave in different ways according to the number of arguments or parameters. And in operator overloading, as I said few minutes ago, that plus operator can be used to add two numbers or used to add two strings. So this plus can have two meanings, or we can add our own meaning to these operators, such as minus, multiplication, divide. We can add our own meanings to all these operators through operator overloading. We can also define function overloading. So this was the basic features of OOP.